Your troubleshooting of erratic behaviors and recurring faults is generally effective, but the cost for lost production time and replacing equipment at your plant are still running high. What do you need to do to turn around the problem? By completing this section of the course, you will improve your ability to identify potential motor and/or drive failures at the lowest possible cost and disruption to your organization. Not every motor drive system merits proactive inspection, and not every problem can be spotted in advance. So, where is the happy median, and what can you do to get ahead of the curve? This training focuses on what you can do to help detect issues like these in advance. The erratic and recurring fault behaviors listed here can often be detected in proactive inspections if you know what to look for. There's a lot of common sense involved in proactive maintenance. It's all about using your time to your best advantage. Which of your systems are the most problematic and the most important to operations? Where do you spend time now compared to how you would like to? Think of it as getting ahead of the curve and reducing the number of times in your week that you get pulled sideways into an unplanned issue through small changes in your team's daily work. Ranking issues is imperative when implementing a proactive maintenance approach. When ranking the importance of each potential issue, consider such factors as where you spend most of your time, relative replacement cost, and any factors particular to your industry, your machine, and your geographical conditions. In the fields next to the issues, rank what you would consider top priorities by entering a number from 1 through 8. When you have filled in all the blanks, click Submit. While priorities may vary from plant to plant depending on a variety of factors, it's important to set up an effective proactive diagnostic framework and concentrate on the most important maintenance issues, which we will look at next. What are some of the most common issues that can be prevented with regular inspections? Use your mouse to roll over the 5 different circled components to discover where the most common preventable faults occur. You must review all 5 components to continue. Remember, though, that proactive maintenance is more than inspecting the system. It also involves training and paperwork. Thankfully, the job of taking, recording, and tracking measurement data has gotten much easier thanks to better tools and smartphone apps that simplify data recording. Maintenance teams are often diverse. They have multiple skill sets and responsibilities represented across various people. There's usually someone focused on the overall uptime and downtime, as well as some people who have more to do on the mechanical side, some that work primarily on controls, and some that do electrical. The trick is knowing who to involve and when to involve them. Because various people monitor different aspects of the same system, it's easy for information to fall through the cracks. If you pool all of the knowledge together in a centralized location, it's much easier to get ahead of the curve. Motor and/or drive failures impact maintenance team members differently. Depending on their responsibilities and skills, it guides how they spend their time every day. Match the pain points on the right with the job to which each corresponds on the left by dragging the correct identifying number of the responsible team member, 1, 2, or 3 on the left, to the blank column on the right. Only the correct numbers will stick. That's correct. These are the pain points for each of 3 jobs. With proactive diagnostics, there are a number of common issues that can be prevented with regular inspections. It's also important to be aware of the issues that require most of your time, and to pool knowledge with others working on the same systems. In the following modules of this section of the course, you will learn how to make the transition from reactive to proactive maintenance, map maintenance best practices to your facility's needs, implement specific motor and/or drive proactive measurements, develop a predictive maintenance framework, and understand what to expect and how to sustain the program. Your troubleshooting of erratic behaviors and recurring faults is generally effective, but the cost for lost production time and replacing equipment at your plant are still running high. What do you need to do to turn around the problem? By completing this lesson, you will improve your ability to implement proactive maintenance and to select the test tools and measurements needed to be most effective. To start, let's examine different industry maintenance practices across all levels to gauge which one works best in different situations. At the minimal maintenance level is what we call reactive maintenance, which is sometimes known as run to failure. That is, no maintenance actions are taken until machinery fails. In truth, this is a very costly approach in today's competitive environment because it only works in environments where machine downtime does not damage critical operations or where teams can afford to replace equipment more frequently. In more critical environments, with perhaps more expensive machinery, teams should move up the maintenance schedule to preventive maintenance, which is generally calendar-based, with tasks scheduled regardless of the actual condition of the equipment. The tasks are completed when the machines are shut down. At the top of the maintenance scale is predictive maintenance, which is condition-based. That is, teams monitor the operating condition of critical assets and take further action when leading indicators of a fault are found. Best practices at this end of the scale depend upon machine types, industry, company culture, and other factors. Both preventative and predictive maintenance are considered proactive. Studies by the Federal Energy Management Program, FEMP, estimate that a properly functioning predictive maintenance program can provide a surprising savings over reactive maintenance. Other independent surveys have determined this savings in a variety of areas. Drag the slider bars to the proper location to discover the average savings in each category. You must locate all 5 correctly to advance. As the answers indicate, these are the areas that should be targeted. Clearly initiating a predictive maintenance program can generate substantial savings. To calculate the savings at your facility, start by estimating the costs of unplanned equipment failures, and then factor in human resources, cost for parts, and the lost revenue from specific production lines. Most maintenance professionals have considered proactive maintenance, but whether they implement it and to what degree often depends on the pros and cons that they see. What are the pros and cons to proactive maintenance that you see? Drag the items on the right to either the pro or con columns. If you are correct, the item will stick. If it bounces, try again. As you can see on the con side, this is how we're used to thinking about proactive maintenance. It takes a lot of time, equipment, scheduling, and software, and it's hard to prove the value. But as we've noted, studies show the return on investment is substantial. Let's see if we can make proactive maintenance easier to implement. Here are the top challenges behind those cons. Additional budget may not be available. What can you do with what you have? People may not be willing to change existing maintenance practices. How do you get their buy-in? Predictive maintenance is a high-end skill. Can current staff manage the planning, inspection, and analysis? Everyone's already working as hard as they can. Where do you find the time for new work? Those are some pretty formidable challenges. The single best way to get around them is to be very strategic with how much you take on and how quickly you do it. This lesson will help you identify which fault conditions are the easiest to identify using maintenance practices within reach of technicians and maintenance managers. If you can't get approval for a large-scale investment, change how you use your existing budget. Take a modular approach and add one capability at a time, and for each addition, have a metric in mind that helps you demonstrate the value of your new practices to senior management. If your team has good technicians, mechanics, and electricians, look into vibration, thermography, and ultrasound. Those technologies are feasible to bring in-house with some basic training and entry-level tools. When it comes to getting buy-in, start with small changes that require little extra effort, and then demonstrate how the new practices can reduce frustration and make everyone look better. No one has extra time. Start with the low-hanging fruit, such as mechanical systems that never receive vibration analysis. Run a pilot program and demonstrate the time and cost savings of proactive versus reactive maintenance. To summarize where to start and what to prioritize on, here's a framework. List all associated assets to be monitored and measured. Prioritize the asset list in order of criticality. Identify what measurements provide leading indicators of asset failure and what thresholds to set alarms at. Match the list of measurements you need to the type of test tools which can collect that data and the software which will trend it. Finally, set up your inspection route and frequency, your core team, and your goals. Who should take which measurements on what assets, how often, for what purpose. The more you can demonstrate the benefits of shifting from reactive to proactive maintenance, the faster you'll win over stakeholders. Think about which of these benefits would be most valuable to your facility. Lower maintenance costs, increase in asset utilization, extension of equipment life, improvement of production quality and capacity, identification of underperforming assets, prevention of equipment failures, and reduction of unscheduled downtime. What are the key benefits when transitioning to proactive maintenance? Click the spin button. When the wheel stops, you will be asked a question. If you answer correctly, you will receive the benefit listed in the circle. If you answer incorrectly, you will be denied that benefit. Let's see whether you're ready to receive the full benefits of transitioning to proactive maintenance. The cost for lost production time caused by electric motor failures is on the rise. According to a plant services survey, 79% of industrial plants have experienced up to 5 days of plant downtime as a result of motor failures. What do you now need to do to turn around the problem? Following best practices for proactive diagnostics will provide your organization with a number of benefits: lower maintenance cost, increase in asset utilization, extension of equipment life, improvement of production quality and capacity, identification of underperforming assets, prevention of equipment failures, reduction of unscheduled downtime, and high return on investment. You are receiving all sorts of erratic behaviors and recurring faults indications. What do you need to do to turn around these issues?
Recurring.
By completing this lesson, you will improve your ability to map out different kinds of motor drive failure modes and determine what tools would be best for screening, diagnosing, and/or correcting the issues. Once you prioritize your maintenance issues at the high level, you're ready to consider the fault types again, erratic behavior and recurring faults, and evaluate what kinds of test tools and measurements are involved to detect them in advance. Proactive maintenance teams use test tools to collect measurements that are key indicators of asset health, such as operating temperature and vibration levels. In order to spot a change in system performance, you need to take the same kind of measurement at the same point on the system time after time, comparing the new measurement against the previous reading or against a known good sample or a go/no-go threshold. Teams use different levels of tools depending on the type of inspection, system, and fault. Screening tools are used for the most frequent inspections to take quick go/no-go measurements for comparison and trending. These tools are often used together to simply spot an apparent change or difference, often saving the results for comparison during the next inspection. Monitoring tools are used when an asset is exhibiting signs of failure and a closer eye is needed to the system. Diagnostic tools are used when a more complex set of measurement data is needed to evaluate a fault condition. Corrective tools are used when proactive maintenance indicates maintenance action is necessary to prevent a fault from occurring. When it comes to screening tools, an infrared camera allows you to see abnormal hotspots that can indicate electrical or electromechanical issues. A leakage current lamp checks for both leakage current issues and insulation degradation while equipment is operational. A vibration meter takes repeatable, severity-scaled readings of overall vibration and bearing condition. Screening tools are used first on the most frequent inspections. Monitoring tools are designed to monitor the problem. A monitoring tool is a sensor that collects and streams a particular measurement at regular intervals. So if you're waiting for a particular change to happen, you can have the sensor keep watch and set an alarm to notify you if conditions change. Wireless monitoring systems are portable and include the sensor, a gateway router, and an app to collect the data. Diagnostic tools are used to analyze the problem. Let's look at the common diagnostic tools. A vibration tester determines the root cause, location, and severity of common mechanical faults. A portable oscilloscope provides a window into the world of electronics, showing you exactly what is occurring over time. An insulation resistance tester applies a test voltage to a motor winding or circuit to stress and test it dynamically. Following the monitor, screening, and diagnosing tools is a tool used to correct the problem. A laser-enabled shaft alignment tool takes the guesswork out of ensuring that the motor and machine are in exact alignment, alleviating stress on critical components. Match the steps in screening your machines on the left with the testing devices on the right by dragging the testing devices on the right to the appropriate open fields. Only the correct answers will stick. That's correct. To begin, we need to screen the machines to find out which ones are good or bad. A thermal imager, various electrical tools, or a vibration meter can tell us which assets have problems. Then, we can use monitoring tools to collect and stream a particular measurement at regular intervals, which help us troubleshoot or diagnose the machine faults and, more importantly, determine a repair recommendation. And finally, we need to correct the problem by using corrective tools such as a laser alignment tool. Developing a predictive maintenance framework improves your ability to map out different kinds of motor drive failure modes and determine what kinds of tools would be best for screening, diagnosing, and/or correcting the issues.